Hi, welcome back. So in this video, we're going to continue our discussion on extreme value theorems and mainly critical numbers today. So the first question says, it says, does the graph below have an absolute maximum? So we want to find out if it has an absolute maximum. So I'm looking for the highest point on the graph. Remember, this is the highest point on the graph. Now, keyword being point. And what do you notice is happening at the vertex? There's a hole. So will this graph have an absolute maximum? And the answer is going to be no. And the reason why, there's a hole where it should be. It has to be a point. You can't have holes in it. You can't have a hole. Because a hole, again, the definition for a hole is it has no value. So let's take a look at example number 3 here. It says, determine the absolute maximum and the absolute minimum for this function. F of x equals 2x minus 3 from negative 1 to 2. Now this one's not that bad to do. Ready? Take a look here. This is just a line. If I were to graph it, I'm starting at negative 3. 1, 2, 3. And let me see. I'm just going to plug in the points here, honestly, because it's a line. If I just plug in negative 1, I'm going to get negative 2 minus 3. So at negative 1, I'm going to be at negative 5. And if I plug in 2, I'm going to be at 1. And it's just a line. So I can easily get my absolute maximum. Well, where's my absolute max? It's going to be at the point 2, 1. Whereas my absolute min, remember, I'm just looking at the point itself. It's going to be at negative 1, and that was at negative 5, was it? And there's our answer. All right, so throughout this year, and even on the AP, we are going to be asked to find absolute max and absolute mins. Tomorrow, we're going to discuss how we can get them algebraically, and then we do some more practice with those the next day. So let's have some practice just finding some critical numbers here. So let's see here. We want to find this derivative. Get the critical numbers. Remember, we want where's the derivative? 0 and d and e. So I'm going to take my derivative. Now, be careful. I don't like cosine like this, so I'm going to write this as cosine squared on the outside. Chain rule, we should get 2 cosine of x times the derivative of cosine, which is negative sine of x, plus the derivative of sine, cosine of x. I want to find out where is the derivative 0. Where does the derivative just not exist? Now, no trig function will ever not just exist, so we don't have to worry about that one, except for like a tangent, things like that. Cosine and sine, they exist everywhere. Next, I want to set the derivative equal to 0. Now, if you're good, and I suspect you are, notice I can factor out a cosine here. So if I factor out a cosine of x, that's going to give me negative 2 sine of x plus 1. Set those equal to 0. We get cosine of x equals 0. And sine of x will equal 1/2. And where does cosine equal 0? Our domain is from 0 to pi over 2. So we get pi over 2, 3 pi over 2. Where is sine equal to 1/2? Well, that's going to be pi over 6 and 5 pi over 6. And there we go. Know thy trig. Know thy trig. All right. Here's a good thing. Absolute value, always sketch absolute value. Always sketch it. So I can graph this from pre-cal last year. I just got to get my vertex. So my vertex is going to be, let's see here. So we want to think of a quick way to get the vertex. A quick way to get the vertex is just this. What will make this 0? What's going to make this 0? And if I do that, x is going to be 3. X equals 3 will make that 0. So I have the point 3, 0. It's positive, so it's going to open up. So where are my critical numbers? Well, my critical numbers are one, where is the derivative equal to 0? Where does the derivative just not exist? Well, nowhere is this a horizontal tangent, so that's not going to happen. But notice that x equals 3, that's a corner. So that's where the slope does not exist. So my critical number is x equals 3. Always graph absolute value. All right, number 3. Well, how do we do this one? Well, we got to take the derivative. That's going to be quotient rule. Low d high minus high, d low, all over the bottom squared. And if I simplify the top, the x's are going to cancel. So we get x minus, so we would get, what's that, x minus 3 minus x minus 1. So we would get negative 4 over x minus 3 cubed. So if I want to find my critical numbers, 1, notice I always put this down. Where does the derivative equal 0? Where does the derivative just not exist? Equal to 0, I'm looking at the top. Negative 4 can never equal 0, so I'm not going to worry about that one. D and E, I'm looking at the bottom. X minus 3 equals 0, so x is 3 is my critical number. It just also happens that this is a vertical asymptote right there, because x can't be 3 in the function either. All right, so go on and try number 4. And let's see here. We get f prime, which is going to equal 1 minus, or plus sine of x, to get your critical numbers. The derivative equals 0, and does the derivative not exist? Never will sine not exist, so that's okay. So the critical numbers is just where does sine of x equal negative 1. And if you notice, what we're going to get here is 3 pi over 2. We don't get the one critical number in that one. Kind of boring. All right, hope you guys enjoyed the video. I'll see you guys soon. Bye-bye.